Welcome to my channel TechneMoira, and for this new year of 2026 I decided I'd learn something new, learning how to solder SMD components with the help of a microscope. So grab your favorite snack or drink, sit back and watch how I stumble and learn.
Okay, I think the chip is more or less positioned where it needs to be. Notice that the chip, the pin 1 on the chip is marked with a little dimple, right? You can see the dimple right there, yeah. And the position 1 on the print board is marked precisely by the number 1 down there. Alright, so there's flux on the chip. So what I'm going to do now is going to heat it up with my soldering iron and apply a little bit of solder This is really not easy. Yeah, it's not easy at all. have to get used to manipulating little parts like this, and you have to be able to do it while watching a screen in front of you, which is counterintuitive here. There you go. Okay, so I soldered pin 1 just to attach, as it were, the IC to the print board. So now I'm going to solder the pin, let me see, pin 9, which is the opposite pin on the other side. Okay, so let me show you. I'm going to show you on screen what I'm doing, but I just want to show you what I'm doing, right? So here we go. There you go. Not the nicest solder point I've made in my life, but I think that will do. Let's see. Okay, so now I can solder the other pins. Trick is to find the right amount of solder, you know, and of course the right amount of solder flux, which is not so easy as it looks. There, that is almost a perfect solder joint. Yeah, it takes a bit of practice. There you go. Yeah, it certainly takes a bit of practice. But uh-oh. Yeah. Okay. Yeah, it's not perfect. That's for sure. But okay. It's not too bad for my first attempt. Now let's solder the other pins. I'm going to turn the PCB around. That's going to make my life a bit easier. So I thought for the holiday season I would make a short ASMR video for you guys to enjoy. Me building a little FM receiver, you know, and it's partially SMD, partially classical components. Um, the reason is I wanted to try my hand at assembling something with SMD components, right? And as it turns out, this receiver is basically has only one real SMD component, and that's the IC. Yeah. So on the screen, you see a still image of the PCB on which I'm going to work, right? So, and this is the actual image right now. Yeah. Um, and this is the record mode. Okay. So what I'm going to do, as you can tell on the slab, there's a tiny little chip right down there, okay, and I'm going to attempt to solder it to the PCB, but in a clean sort of way, okay. So I'll admit to you guys that I've never done any SMD soldering, as it were, until now, and I thought I would let you guys enjoy me getting to grips with how to solder cleanly SMD components. Now, before I stop talking and let you enjoy me struggling soldering SMD components and such, I bought this setup you see here, okay, a few months ago actually. I bought this whole magnifier thing a few months ago, and I just didn't buy it, you know, willy-nilly. I did some research, and this one came out as, let's say, best buy for your money. Okay. I learned how to, you know, how to use it. It's not too hard to do. It's the menus are rather how to say, intuitive. Okay, so it's not a steep learning curve to learn to use it. I did have to buy, of course, a few extras with it to be able to do some SMD soldering, and one of the extra tools I had to buy was these tweezers here. Now, these tweezers are a bit special in the sense that you know, usually tweezers are metal, right? But these tweezers have ceramic endings, you know. So, and I bought these because ceramic extensions, let's say, are heat resistant, and they are also non-conductive, you know, which is pretty essential if you're going to use integrated circuits, okay, because integrated circuits are really, really sensitive to static electricity and all that, and these ceramic grippers are in fact perfect insulators, and they can withstand heat perfectly. Yeah. Uh, as opposed to these tweezers, these are metal tweezers. Uh, I bought these because I want to be able to manipulate parts which are not, let's say, static electricity sensitive. Yeah. These tweezers are stainless steel and have extremely sharp tips, you know, which allow me to manipulate very, very small components. Okay. Alright, so I bought these tweezers, these two tweezers. I also bought a whole bunch of flux, as you can tell. I have liquid flux, which supposedly leaves no traces after use. And I bought quote-unquote classic flux, okay, which is more paste. This is liquidy, yeah. Uh, this flux is more like a paste. Alright, so but now I'm going to try to use the paste type of flux. For solder, I'm going to use classic solder, you see here, and that's when I say classic, I mean it's solder, let's see, it's 60-40. So it's 60% tin, 40% silver, I think. Okay. So yeah, there you go. I'm going to use classic solder, uh, also with some solder rosin included in the solder itself. Yeah. Finally, what I'm going to use is a small, a small soldering iron, 60 watt. Okay. Don't know if you guys can see this. Yeah, there you go. Okay, so I'm going to use a 60 watt soldering iron. I don't know why it doesn't. Okay, there. So I'm going to use a 60 watt soldering iron set to let's see, set to 400 degrees Celsius. Okay. It too also has a very sharp point, which allows me to direct the heat to a very specific point on the PCB. Alright, and then to top it all off, I also have a hot air blower. Alright, which allows me to use hot air to solder components, SMD components. But tonight I'm not going to use this because it's a bit too loud. I don't want to bother my neighbors, first of all. Second of all, I think personally, I think this is better to unsolder SMD components rather than to solder them. Now, if I bodge the soldering job you see on the slab, it might still be possible that I'll have to use the hot air blower to correct my problem. So you see on the screen that I'm going to solder next a component which is called an RDA 5807, which is basically a specialized little chip which allows you to make a scanning FM receiver. Okay, so it's tiny little receiver, and I bought this just as a test, uh, to see how well I'll do, you know. Um, so, and if I bodge it completely, it's, I don't know, it's like $3 or so, or $4. It's really not expensive. So I didn't want to use very expensive stuff. Okay. Also, I'm holding the, if you look at the base of my microscope, I'm using a little plastic clamp to keep the PCB in place. Alright. I'm also not using my LED spotlights to full brightness, because if I do, I oversaturate the image you see on the screen of the microscope. Yeah. So using the brightness I've set now is perfect for working on the microscope. Okay, enough talking. The microscope seems to agree with me. I should stop talking and I should get on with it. Alright, I cleaned the surface of the chip with a little bit of acetone because, well, it was, the flux residue was way more persistent than I thought it would be. And then I used a simple little brush, a painter's brush, with some stiff bristles to clean off the rest of the excess on the chip, right? So there you go. I did my best to make the soldering job as clean as possible, and I'm sure you can tell that the job is not too bad. Okay, I mean, for my first attempt, I would say this is really not bad at all. Do I need to improve? Yes, of course. But I mean, what I do notice is that I will need to apply more flux. Yeah, so adding more flux certainly makes it a lot easier to solder, and I will need to keep my solder wick close at hand, at least in the beginning, you know. As long as I'm not used to working with this sort of stuff. Also, what I also advise is to keep the tip of your soldering iron always as clean as possible. And to do that, I use a special brush. Yeah, well, special. Let's say I use a brush with not with copper bristles, but with I can't remember the name of the metal, but brass, that's it. So I'm using a brass bristled brush to clean off the tip of my soldering iron, and that is really perfect. You know, it doesn't damage the tip of your soldering iron, and it keeps it really, really clean. So there you go. I soldered the chip, all right, and it I tested all the pins of the IC with my metal tweezers just to make sure that they were all soldered correctly and they didn't budge, yeah, and they don't move, so that's perfect. And the chip is perfectly aligned on the PCB. So I can move on now with soldering other parts. Alright, for those of you who are novices or beginners in electronics, when you look at an electrolytic capacitor, okay, an electrolytic capacitor has a polarity, okay, it has a negative or a cathode indicated generally by a line, you know, like this, a white line on black background, but it can have another color. But generally you see the minus symbol in the line. Okay, so let me show you from close up. Okay, so the cathode of the capacitor is generally, of an electrolytic capacitor, is generally indicated by a minus symbol, okay, which is generally painted in the center of a fat line like this. Alright, so that's the negative of the electrolytic capacitor. The other lead on the other side is a positive, or the anode. Now generally the anode on an electrolytic capacitor, certainly a radial capacitor like this, is the lead is longer than the negative or the cathode. Okay, so you can always recognize the anode or the positive lead of an electrolytic capacitor by its length and its position. Alright, so long lead, anode or positive, short lead, negative or cathode. When I solder components, like for example the electrolytic here, I never solder both pins at the same time, or let's say I rarely solder both pins at the same time. And the reason for that is that if I solder just one of the leads or one of the pins, it allows me to improve a little bit the position of the component on the PCB, and call it OCD if you wish, but I like to have my components perfectly aligned on the PCB. Alright, I hope I can finish soldering up all the parts I've got left over on the PCB, and then hopefully I'll be able to test it, right? So fortunately for me, at the back of the PCB is marked which components are which, yeah? I mean, which components I need to place, which ones I was supplied with the little PCB. Okay, now the way I go about it is I solder first the smallest parts on the board, so the resistors, the capacitors, the transistors, even the chip, you know, and once all the smallest parts are installed, you know, like the diodes and what have you not, then I finish up installing all the largest parts. Now, in case you're wondering why progress is so slow on mounting the components of on the PCB, well, that is the reason why. Okay, right now it's 10 degrees C in my lab, right? So it's pretty cold in here. So, but I switched on the heater, so I'm hoping soon it'll be warm enough to work. The 33 picofarad capacitor is marked with a black dot on the top, right? So C4 is a 33 picofarad and it's an NPO, which means that it drifts in capacitance by 0%, you know. So it's a very solid, very stable capacitor. And for good reason, because this 33 picofarad capacitor is used in a high frequency oscillator circuit, right? And you want the capacitance to stay absolutely stable, right? So C4 is a 33 picofarad. Now there are two more disk capacitors I need to install, and both of them are of the value. Let me show you. Let me take, okay, this one for example. So this one is marked 104, right? So 104 is, in fact, you have to interpret that as a 10 with 4 extra zeros after it. Okay, that's how you read this. Okay, so it means 10 and 4 more zeros, which is in fact 100,000, and you have to read that as 100,000 picofarad, or divided by 1000 is 10 nanofarad. Okay, so this is basically a 10 nanofarad capacitor. Alright, so there are two of these that I need to mount. One more tip I want to give you is, as you have probably noticed, this PCB is double-sided, which means that there are copper pads which need to be soldered on both sides of the PCB, right? So this is the top side of the PCB, and this is the back side of the PCB. All right. So, and you need to solder the contacts of the leads on both sides of the PCB. All right. So, which also means that you need to check your solder work after you're done, top side as well. Okay, and you need to check whether the leads are sufficiently soldered top side as well. Alright, so what we're going to mount next is 4 more components, namely 2 diodes, 1 coil, and 1 oscillator crystal. Okay, now let me show you. The diode generally looks a little bit like this. Okay, so I don't know if you guys can see this, but alright. So most of the time diodes have a black stripe at the end, you know. And a diode is a polarized component, which means that it has an anode or a positive pole and a cathode or a negative pole. The end indicated by the black stripe is the cathode, alright? So, which means the negative end. Yeah, you can't be wrong. If you once you identify the cathode, you know, of course, what the other end is. This diode specifically is a 1N4148, so which is a fast switching diode. Alright, so, and you bend the leads, in this case at least, as close as possible, but with gentle force, to the body of the diode, okay? Don't try to bend these leads in a perfect 90-degree bend, because then you will break the diode, okay? Just keep it bent like this and you'll be fine. The other component I'm going to mount is a coil, yeah, and you can recognize coils, high frequency coils, most of the time by their color, yeah. Whereas resistors are often either beige or blue, coils are often green, like this one. Alright? So that's how you identify a coil. And then you have a crystal. By the way, coils have no polarity. Okay, so it doesn't matter in which way you mount the direction in which you mount a coil has absolutely no importance, since the coil has no polarity. Okay, and the same goes for a crystal, you know. And this particular crystal is a very small crystal. Generally, crystals used for oscillators are encased in a metal casing like this. It can be a squarish or a rectangular case, slightly larger than this, or in this case, a cylindrical metallic case. Okay, a crystal has two leads. Okay, but it has no polarity. So in effect, you can mount a crystal in any direction. It really doesn't matter, since the crystal has no polarity at all. Now, on the PCB, the crystal, in this case, is indicated by that symbol over there. You see that? Y with two brackets? That's where you need to mount the crystal. The coil, on the other hand, is indicated by the symbol L1. Come on, focus. Focus. There. Alright, so a little squiggly line and the symbol L1. So that's the coil. Alright, and by the way, at the back, no, is not indicated which component is the coil. So, or rather, sorry, it is. You see here, L1 is 100 microhenry. So, coils are indicated in Henry, yeah, or in this case microhenry. Capacitors are indicated in farad. Okay, so picofarad, nanofarad, microfarad. All right. So the diodes will have to be mounted at this position here. You see D1, D2, and you see the white stripe on the PCB. That indicates the direction of the cathode. Alright, there you go. Alright, all the components are mounted, as you can tell. I checked all the solder points and they look fine, but of course, like they usually say, the proof is in the tasting, right? So the proof of the pudding is in the tasting. So what I'm going to do is I'm going to hook up the PCB to my lab power supply and connect a headphone to it and a little antenna, and then we'll test it. Okay, so by the way, you see here position A here where I'm pointing at. That is supposed to be an antenna connector. Okay, so you can connect up a wire of a certain length to it to be used as an antenna. Alright, I'm getting ready to demonstrate the little FM radio I built to teach myself some skills to solder SMD components and, well, generally speaking, very small components with the help of a microscope like the one you see right in front of you. Now, what I at first thought to be a completely useless accessory for the microscope, which is this tiny little remote which is connected to it via a wire, yeah, is actually very handy because, as you know, the smaller the features are that you need to film, even the tiniest movement will make the whole image shake. So obviously, if you want to start or stop the recording, then doing it via a remote is certainly a big advantage. So in the end, no, this remote is not superfluous. You really need one to be able to, let's say, use the microscope. Okay? So anyway, what I built with the help of this microscope is a little kit I bought online. Yeah, and it didn't cost much. I think, if I remember correctly, it cost me somewhere around $5 or so. So, except of course the battery holder wasn't included, and neither was a headphone. Okay, all the rest, all the parts you see right in front of you were included. Now, I tested out all the functions and they do seem to work, except for the little jumper here. So I tried to look it up what that jumper might do on the original page where I bought this kit, and I just couldn't find the page anymore where I ordered this kit. So I'm afraid I'll have to, yeah, I'll have to look for an answer somewhere else, or maybe some of you might know it, but I certainly don't. What I did find out is that you do need a small antenna. So you do need to connect up a wire, even a short wire, to the antenna input, which is that pin there where I'm pointing at, okay? there's a little A in the left upper corner of it. Now, what I did find out is that if you connect the antenna to the shielding of your headphone connector, and of course you connect your headphones up to it, then your headphones will basically function as a large antenna, and that does improve the reception. Okay. Otherwise, well, it's fairly simple in use. So the button, which is labeled as PSW, is the power switch. Then you have vol minus a vol plus, which obviously means lower the volume or raise the volume. And then you have seek minus and seek positive, which means of course scanning the whole FM band, but with this proviso that it scans from 78 megahertz up to 108, which doesn't work in every country in the world. Okay, so in Europe the FM band starts at 88 megahertz and ends somewhere around 106 megahertz. I don't know what that would be in the States or in Canada. I think in Japan you do have FM stations around the 76 or 78 megahertz, right? So anyway, there you go. Now, I could have hooked it up to my headphones and tried to record it for you people, but unfortunately the signal to the headphone is just too weak to be picked up from my camera, you know, or by my camera. So I had to hook it up to a small computer speaker amplifier. Okay, so it is stereo, by the way. So what I'm going to do is I'm going to quickly scan through all the stations, and I'm not going to linger on any particular station, but I'm just going to start the scan quickly to let you hear well, what you can receive with such a small FM receiver. By the way, it is powered by two AA 1.5 volt batteries in series, so which means roughly 3 volts. Okay, you can go up to 3.3 volts if you wish, but I wouldn't go much higher than that. I mean, the chip you see on the print board is designed to handle up to 3.3 volts, but not higher. Alright, so okay, here we go. Power switch. Alright, now let's scan.
Kost me tijd om door te gaan.
I'm always seeking upwards.
Move across you, you can't take it.
Ik ben meestal, in de meeste van mijn dromen ben ik heel erg oud.
Ja?
Ben ik echt een oud.
Dat betekent dat je een oude ziel bent dan?
Dat zou wel eens kunnen
Ja.
kloppen, dat hoor ik al heel mijn leven eigenlijk.
Ah
Ja.
ja, oké. En hoe oud dan? Hoe oud is oud?
Eind 70, tussen de 6 en de 79, zoiets.
Allee, oké.
Ja.
Dat kan dan ook betekenen dat je echt wel zo oud gaat worden. Dat is ook wel fijn. Hè?
Mogelijk wel, of
zou
misschien dat
kunnen.
ik nu op mijn 35 eigenlijk al met een beeld heb.
Ik leef in een film. naar je zien opnieuw. Het stormen als je huilt. Laat het waaien als je kijkt. Everybody does. You can wait for the weekend.
Okay, there you go. We we scanned the FM band full circle. Yeah, the sound quality isn't great, and I don't think that was the intention of this kit. It was only meant as an exercise for mounting an SMD component, right? So how to teach somebody how to solder SMD components, and I would say, yeah, it worked out pretty well, although I have to admit that the solder points, the solder points I soldered around the chip, although they are functional, they are not pretty. Yeah, I've seen far prettier soldering than that. But I mean, I think with a little bit of exercise, I can improve the quality of my SMD soldering, right? So yeah, it worked out fine, and yeah, for a cheap little kit, it's fun to do. Obviously, you when you're going to mount or solder an SMD component, you do need a few more tools. If you have really sharp eyes, you can get away with using a light source with a built-in magnifier like this, instead of using a microscope like that. But if, like me, your eyesight is not perfect anymore, and in fact it's far from perfect, then you will need a magnifier, well, a microscope like this. And this microscope, if I remember correctly, cost me somewhere in the region of $80. Okay. No, well, it's not my intention to do some sort of testing of the microscope for you guys, unless of course some of you would request it, or quite a few of you would request it, that I'm willing to do a special video just to evaluate this particular microscope, okay? But so far I'm not too disappointed. So there you go. A weekend project, namely mounting an SMD kit with minimal tools, and it works. Not super hi-fi quality sound, but it works nonetheless. So there you go. I'm going to end the video now, but I want to wish you all a happy new year, although somewhat belated, I suppose, but still a happy, successful 2026, and I hope I will see all of you soon back on my channel. Thanks for watching, and always welcome. Bye.